Alright, now let's look at emission or loss of an alpha particle, a beta particle, or a gamma radiation. But before that, let's understand a parent nuclide and then a daughter nuclide. What is a parent nuclide and what is a daughter nuclide? So over here, in the beginning, I explained using this example to illustrate natural reductivity. So over here, the uranium, which is going to disintegrate or break down to produce a new element or a new nuclide with the emission of this radiation, the uranium here becomes a parent nuclide. So the uranium here is the parent nuclide. And then the new element formed, or the new nuclide formed after the disintegration, is known as the daughter nuclide. So our TH here becomes the daughter nuclide. Is that okay? So over here, the next example here, our PB becomes the parent nuclide, and then the BI becomes the daughter nuclide. Is that okay? So the radioactive element which undergoes the disintegration is known as the parent nuclide. And the one that is formed after the disintegration or the breakdown or the decay is known as the daughter nuclide. Is that okay? Now let's go through emission or loss of an alpha particle. When a radioactive element undergoes alpha decay or alpha emission or a loss of an alpha particle, what is the meaning? It means that anytime a radioactive element undergoes an alpha emission, one, the daughter nuclide reduces by 4 in terms of its mass number, and then its proton number also reduces by 2. So I've written reduction of 4 in the mass number and reduction of 2 in the atomic number of the daughter nuclide. So let's take an example. So I have Ra as the parent nuclide. It has a mass of 226 and a proton of 88. Ra is undergoing a spontaneous decay to emit an alpha particle or an alpha emission. Once there's an alpha emission, it simply means that the mass of the parent nuclide compared to the mass of the daughter nuclide will have a reduction in 4 compared to the parent nuclide regarding its mass. So since the mass here is 226, there's going to be a reduction of 4 for the daughter. So it's going to have a mass of 222. So that is 226 minus 4 will give us 222. Is that okay? 222. And then the proton number is going to reduce by 2. So we are going to get 86. Is that okay? For the daughter nuclide. Once this happens, it means that there's an emission of an alpha particle. So an alpha particle leads to the reduction of 4 in the mass number of the daughter nuclide and a reduction of 2 in the proton number of the daughter nuclide compared to that of the parent nuclide. Is that okay? That is an alpha emission. So we can use this example here as well. So since an alpha particle is emitted here, it means that comparing the mass of the parent to the daughter will have a reduction in 4. So we are going to get 2, 3, 4. And then a reduction in 2 in its proton or atomic number. Is that okay? It means that there is an alpha emission or a loss of an alpha particle. Is that okay? Are we following? Yes, so that is alpha emission or an alpha decay. In alpha decay, the daughter nuclide reduces its mass by 4 compared to the parent nuclide, and its atomic number reduces by 2 compared to the parent nuclide as well. Now let's move on to the next emission, that is beta emission or loss of a beta particle. With the loss of a beta particle, the mass of both the parent and the daughter nuclide remains the same. There's no changes in the mass. But the proton number of the daughter nuclide increases by 1. The proton number of the daughter nuclide increases by 1, but the mass of both the daughter and the parent nuclide remains the same. But the proton or the atomic number increases by 1 for the daughter nuclide compared to the parent nuclide. Is that okay? So, increase in atomic number by 1 of the daughter nuclide, no change in mass number of the daughter nuclide. That is emission or loss of a beta particle. Now let's take an example here. So over here, PV releases a radiation, and the radiation is a beta radiation. Is that okay? Once a beta radiation is emitted, the daughter nuclide that is coming from the parent nuclide will have the same mass as the parent. The mass remains the same. But the atomic number or the proton number increases by 1. So here it is 82 for the parent. The daughter is going to increase by 1, so it will be what? 83. It indicates the emission of a beta radiation or a beta particle. So for beta particle or beta emission, the daughter nuclide increases by 1 in its atomic number compared to the parent 1, but the mass remains the same. That is beta emission. That is beta emission or beta decay or loss of beta particle. Is that okay? Now the last one. Now the last one is the emission or loss of gamma rays. Emission or loss of gamma rays. So with the gamma ray emission, both the atomic number and mass number remains the same. There's no changes regarding the atomic number or the mass number. Between the daughter and then the parent nuclide, it remains the same. There's no changes. The proton or atomic number of the parent, the proton or atomic number of the daughter is the same. The mass number of the parent and the mass number of the daughter is still the same. So for example, if Sn is undergoing a gamma decay, or it is going to release a gamma radiation, it means that you are going to still get the same thing with the release of this gamma radiation. So comparing the parent nuclide and then the daughter nuclide, they all have the same proton number, the same mass number as well. Is that okay? If a radioactive element emits a gamma radiation, both the proton number of the parent and the daughter remains the same. There's no changes. The same thing applies to the mass number as well. So this is emission or loss of alpha particle, beta particle, and gamma particle as well. Is that okay? Now, let's strike some basic differences between nuclear reactions and chemical reactions. Difference between nuclear reactions and chemical reactions.